Well, anyway, so we will wait 1 more minute for the others. Right, so anyone who has a question so far? So were all of you able to pass my electrical circuits? So if there is someone uh, who's INC, okay, so please message me. So you still have a chance. Okay? So you must take the completion in order for you to pass the subject. Well, anyway, so are you guys now ready for the continuation of our discussion? Hello, hello. Are you guys still around?
Sure.
Okay. So, huwag muna kayo matutulog. Okay. So, we'll try to finish this one as soon as I can. Okay. So, the next one is potentiometers. Okay. So, to make it short, this is a resistor wherein we can control the value of the resistor. Okay. So, let's see from left to right, it's increasing evenly like 10 ohms, 20 ohms, 30 ohms, 40 ohms, and then 50 ohms. Okay. So this one depends on the potentiometer. So we have 10K potentiometer. We have, I don't know if we have 100K or 1K, but yeah. So from let's say 1K to 2K, 3K, 4K, 5K, 6K, up to 10K of a value of resistor. Okay. And then we have here LEDs. So you guys already know this one. And then of course this one is polarized. Okay, polarized diode. So it's a light emitting diode. So we're in just by putting here the negative and then positive, this will lit up. Okay. So of course this one is the cathode and then this one is the anode. All right. So I will not explain much more in here since you guys already know this one for sure. And then the next one is switches. So we have a lot of kinds of switch, but it only has a one goal, wherein a switch is basically a mechanical device that creates a break in a circuit. So it could break or close a certain circuit. So we have this kind of circuits wherein we have normally open, wherein by default, of course, they are open. Okay, and then if you're going to turn on that one, it will uh, let's see, close the path. And then we have the normally closed. By default, it's already closed. So if you're going to activate that one, then it will open the connectivity. Okay. So we also have this SPDP or the single pole double throw switch, wherein it can boot open one connection and lose another when activated. So pag parang ganito siya tatlo. So if it's on the right side, this will be connected. So it can connect two devices. And then if it's on the left side, it will deactivate the other two, and then it will activate another two. Okay, or another one. Okay, sorry. So ito yung isa lang, it will activate and then deactivate one uh, switch, okay, or part of your device. But when we say DPDP, so this will now activate two and then will deactivate two. Vice versa, ganun din. Okay, so this one is single and then this one is the double. All right, so we call this one SPDP or the single pole double throw switch, and another one is DPDP or the double pole double throw switch. Okay, so siguro may mga gamit din to na kung saan kailangan talagang ganito. Okay, it's just that I never encountered this kind of switch. So mostly nasa single lang tayo. So it's either on or off. Yun lang yung mostly na gamit ko Okay, so maybe in a big industry, they're using this kind of switch. Okay, and then batteries. So this is a very, very simple batteries. Batteries store energy or a container which converts chemical energy into electricity. Okay, so we have different kinds of batteries. So we have double A, triple A. Okay, and then in here it's just explaining that if you're going to connect them in series. Okay, so let's say three 1.5 volt double A battery, so it will give you a 4.5 volts. So if you're connecting battery in series, you are increasing the voltage. Okay, so am I recording this one?
Yes, sir.
Good. Kala ko hindi ko napindot yung record button. Anyway, and if you are connecting batteries in parallel, so the voltage will still remain, so 1.5 volts pa lang. However, you are increasing the current. Okay, so if let's say 1.5 volts is 1 amp, and then just by adding another one, it will give you now 2 amps total of current, okay, flow of current. So yun lang naman yung pinagkaiba nila. Okay, so if you want to increase the voltage itself, then you must uh, put them or place them in a series connection. But if you want to increase the current, then you must place them in a parallel connection. Okay, and then breadboards. So I hope you guys have already seen one of these in actual. Okay, and then I hope you guys have already tried using this one. So mostly second year pa lang to electronics, electrics, fundamental of electrics yung electrics 1. So dapat dun pa lang alam niyo na kung paano gamitin 'to. Okay, kasi dito niyo ma-experience kung paano magpagana ng LED, paano gumamit ng resistor using their values. Okay, so yeah, I encourage you guys to invest. Mura lang naman to, I think less than 100 pesos lang naman. And then yung mga ibang components is mura lang din naman, like resistors are 5 pesos, 10 pesos. Same with LEDs. And then gamit na lang kayo ng battery, okay, as your power supply, since maliliit na components lang naman yan. Okay, so try to play with this one. So hindi man siya project, okay, or wala man kayong idea, just know or just learn how to use a breadboard. Okay, so very important. Okay, so di ko na siya babasahin. Let's just explain the breadboard using the picture itself. So palakihin ko na lang. Magiging pixelated nga lang. Anyway, so mostly the right side and the left side is where we place our power supply, the positive and negative. So the red line that you guys are seeing right here, meaning this one is connected from here up to here. Okay? But I think hindi siya connected talaga. I think you need to use a jumper right here. So you need to connect this one to here. Okay, in order for you to see that this one is connected. Okay, but that's the flow of current in here. So they are in vertical. So ganito yung connection nila. And then the one that is in the middle, okay, this is where you put your components. And then the connected rows right here is this one. So in horizontal naman siya. So if you want to connect this row to this row, okay, so dapat meron kang jumper dito. Okay. So same with this one, you need to have a jumper, 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 jumper. So with that, this one now is connected from end to end. This one and this one. Okay. Well, anyway, so that's how you use a breadboard. Alright. And then wires. So dito naman, ang tinitignan lang natin is yung kung gaano ba kalaki. Yung gauge mismo. Merong 10 gauge, 22 gauge. So for the breadboards, this one is recommended. So 22 gauge. Meron iba mas payat pa, meron iba mas mataba. So just do take note that wires consumes, hindi naman consumes, parang it has a resistor in it. So let's say 5 volts, magiging 4.9 volts na lang. Okay, kung mas mataba pa, magiging 4.8 volts na lang. yung reading mo. So, depende yun sa layo. Okay, and then depende rin yun sa taba ng wire na gagamitin mo. Okay, so black and red, so they are just the same, but mostly, of course, we use black for ground or negative, and then red one is for the positive. Okay, so common knowledge niyo, so wag niyong pagpapalitin. So in case na may kakalikot mismo ng device na ginawa nyo, they know that this is the positive side and then this is the negative side. Okay. All right, so next one is semiconductors. So let's now talk about what is a semiconductor. So semiconductors are used extensively in electronic circuits. As its name implies, semiconductor is a material that conducts current, but only partly. Okay, so let's just say that in conductor, okay, it conducts 100%. Okay, and in insulator, let's say it conducts maybe it doesn't conduct. I'm sorry, it doesn't conduct 90 to 100%, but pwede pa rin, kaya nga 90 to 100% eh. And then semiconductors, so it conducts 50% and then it doesn't conduct 50%. So parang 50-50. So nasa gitna siya ng conductor and insulator. Okay? And then most semiconductors are crystals made of certain materials are most commonly silicon. Okay. And silicon is used extensively as semiconductor in solid state devices. Okay, or the SSD, the one that we have in our computers. So yun yung upgraded ng HDD in a computer and micro electronic devices. So here are the other usage of silicon. So here they can also be used in dynamo or transformer plates and many more. Okay, hindi lang na lagay dito. Okay, and then silicones. Okay, so this is a different one. So silicon is the element itself, the one that we can find on the periodic table of elements. So this is an element, but yeah, this is also an element, but this is not the one that we are using in electronics. So ito yung silicone, yung silicone oil. This one is being used in cosmetics, hair conditioners, sealant, okay, or yung mga implants, breast implant, okay, yung mga yun for surgeries. Okay, so just do take note that silicon and then silicone are two different things. All right. So let's now move on to the other examples of semiconductors. Okay, which is this anong kulay nito? This is like blue-green. Okay, this one, the boron, silicon, germanium, arsenic, stibum, and so on and so forth. So we do call this one the staircase, a metallite staircase. Okay, this one. So itong parang green na to. Okay, those are semiconductors. But there is only two, okay, or there are only two semiconductors that's really being used when it comes to the industry, because the others is doesn't work perfectly. So since we're talking about semiconductors, and semiconductors supposedly must only have exactly they must exactly have 4 electrons only. But in some of the semiconductors, some of them are 3 electrons, some of them are 5. Okay, which we don't want that one. Okay, kailangan perfect semiconductor siya. Hindi pwedeng 40%, hindi pwedeng 60%. It must be exactly 50%. Okay, so after silicon, okay, oops, dito muna tayo. So other example semiconductors are germanium, gallium arsenide, and elements near to the so-called metallite staircase, which is this one. Then after silicon, gallium arsenide is the second most semiconductor and is used in laser diodes, solar cells, microwave, frequency integrated circuits, and then others. Okay, so yung iba, ginagamit pa rin naman siguro sila sa ibang purpose or ibang devices. But mostly when we see semiconductors, we only have 2. Okay, or let's say 3. Pwedeng 3 siguro. So the first one is the silicon. This is the perfect semiconductor. So the second one is germanium or the gallium arsenide. So yung tatlong yun lang. Okay, so you will know later on why those 3 only. Why we cannot use arsenic, stibum, I don't know what is one. Yeah, those three. So, hindi masyadong nagagamit yung mga yan. So, how are elements made? So, again, we have this like bond. So, I hope alam na natutunan nyo na to sa physics. We have this covalent bonds. And then, just by combining elements, it can come up with another elements. Okay, like for example, this one, combining a hydrogen and an oxygen. So, it will give you H2O, I guess, hydrogen. Ba yun? I now forgot. Yeah, H2O. Ano to? Hydrogen? Ano na kasi yan? Hydrogen oxide. Yeah, hydrogen oxide. So, nakalimutan ko na kung anong H2O. But yeah, H2O is water. But yeah, combining hydrogen and oxygen, it will give you a water. So, the electrons is an atom are organized in layers. So, these layers are called shells. And then the outermost shell is called the valence shell. Ito. So whatever is our outer shell, that is the one that is attracting other elements that can, para sila mag-meet. Okay, electron to electron, and then mag-meet sila. And then kapag nabuo to, and then it will come up with another elements. Okay, so just do take note that in semiconductors, okay, typically have 4 electrons in their valence shell. So apat na side yan. Okay, so if all neighboring atoms are of the same type, it's possible for all the valence electrons to bind with valence electrons from other atoms. Okay, when that happens, the atoms arrange themselves in the structures called crystals, usually silicon crystals. Okay, so again, let's just recall, ito yung hinahanap ko kanina, bakit pa ako pumunta doon. Yeah, semiconductors is again ranging from 1 to 3, and semiconductors has exactly 4 electrons. Okay, kapag sobra dyan, kapag 5, that's already considered as insulator. Okay, and then kapag bumaba naman, kapag 3, that's already considered as conductor. Okay, so here, the reason why silicon is the perfect semiconductor. Okay, because silicon has 4 electrons, so this side, and then this side, and then this side. And then if it's a pure silicon, so you're forming a pure perfect semiconductor. Okay, since apat lahat, as you guys can see, apat lahat. Okay, since this is a pure silicon. However, okay, dito muna tayo. Balik tayo dito mamaya sa 2 types of semiconductor. However, if we have here antimony or the stibbium, so those are just the same. So as you guys can see right here, I hope you guys can see this one. Okay, so as you guys can see right here, we have the antimony, and then it's being surrounded by silicon. So all of the silicons has 4 electrons, of course, but a stibbium has a 5th valence electron of antimony. So in here, you're not creating a perfect semiconductor anymore. So parang impure na siya. Okay, may halo na siyang stibbium, which is more on insulator. Okay, so this one is not good as a semiconductor because this one now is falling as an insulator. Okay, this is not working as a semiconductor anymore. And then the other one, which is the boron. Okay, so the same. So this one is being surrounded by silicon, so 4 electrons, but the boron has only 3 electrons. So again, when we say 3 electrons, okay, it falls on the conductors. So ganun din, hindi rin siya perfect as a semiconductor kasi nagiging more on the conducting side na siya. Okay, so if you want a perfect semiconductor, all of them must be silicons. Okay, like this one. Okay, so are you guys getting the idea so far on why silicon is the perfect semiconductor? Hello, hello. Are you guys still listening? Any questions so far?
Enter. Naman po, sir.
All right, so let us now talk about the 2 types of semiconductors. We have the N-type and then the P-type. So for the N-type, meaning there's more excess of electrons in here, okay, in this kind of semiconductor. And then for the p-type, I think it's very obvious, okay. It has a shortage of electrons, meaning there's more hole on this type of semiconductor, okay. N-type, mas maraming electrons. P-type, mas maraming hole. So the hole right here is like, let's just say that it's the proton, the positive one, because electron is the negative one. Okay? So, ganun lang kasimple kapag sinabi natin N-type and then P-type. Okay? And then in here, so we have the N-type. So, majority, when we see majority, it has more that kind of elements. So, N-type, it has more negative elements or electron on that material. And then P-type, it has more hole, or the majority carrier is a proton or positive. Okay, so ganoon lang siya kasimple. So this one, the white one is the proton or the holes, and then the N-type, okay, so it has more electrons, which is the orange. Okay, and then the next one is diode. So ito rin yung pinaka-focus ng electronics. So let's talk about the two sides of diodes first. So this side is the anode, and then this one is the cathode. So wag na wag niyong pagpapalitin. Okay, this is very important. Polarity is very, very important. Okay, so this is the positive one, and then this is the negative one. Okay, and then in actual, ito siya. So yung mas maliit or the gray one is the cathode, and then the black one is the positive side. All right. So electronic devices created by bringing together a p-type and n-type region within the same semiconductor lattice. So ito yung mismong diode natin. Okay, we have the N region and then we have the P region. Okay, there is actually one more. Okay, yung pinakamaliit, yung nasa gitna. We call this one the depletion region. So all in all, we have three regions in a diode. We have the P region, the N region, and then the depletion region. So later on, we'll discuss more what is the depletion region. But yeah, when I say N region, this one contains the electrons, and then P region, this one contains the holes, okay, or the proton. All right, so let's talk about diodes now. When it comes to any kinds of diodes. So lahat sila ganito naman yung representation. So laging merong hole, meron laging electrons, and then we have the depletion region. So mapa-germanium man yan, or mapa-silicon, or mapa-boron, or mapa kung anumang semiconductor yan. Okay? So in here, the narrower the depletion region, the more chance that there is a flow of electricity. Okay, and then the wider the depletion region, the more chance that it's blocking the flow of electricity. So I think video to eh. Yeah. Hindi nga pala gumagana sa PDF. Okay. Wait lang. Balikan natin sa kasi dito GIF siya. Actually, check. Video siya. Right. So, as you guys can see right here, okay, so sa ano muna tayo, sa forward bias. So when you say forward bias, meaning your negative is connected to your cathode, and then your positive is connected to your anode. Meaning we have the proper proper orientation or the proper connection. Okay, so kapag forward bias, of course, merong flow of electricity. Okay, and then as you guys can see, the hole and then the electrons is like meeting, okay, on the depletion region. So kapag nagmi-meet sila, ang nangyayari niyan, mas lumiliit yung depletion region natin. Okay? So mas maliit yung depletion region, the more electricity that can flow on this path right here. Okay? Pero kapag wala bang so walang reverse bias. Well, anyway, so this is the forward bias. And then if it's open, so if it's open, so wala mangyayari, of course, since wala namang tumutulak mismo dun sa electron and then hole natin para mag-meet sila. But yeah, that's the idea. So later on, I hope meron pang pictures yan. Meron pa nga. So dito na tayo. So I think I was able to explain everything already. Yeah. So ito na lang. Depletion region. This region of uncovered positive and negative ions is called the depletion region due to the depletion of carriers in this region. Okay. So dito sila actually parang naglalaho. Kapag nag-meet sila, parang nagkakaroon na ng connection doon and then nagiging electricity. Okay. And then kapag hindi sila nag-meet, meaning it's blocking the way of electricity. Okay, so let's start with no bias first. So kapag open, okay, open circuit, so of course nothing's happening. So meron tayong mix of electrons and holes, but of course zero yung current natin since 0 volts yung in-apply natin mismo dito. And then second one is the forward bias. Okay, so positive to the p-type and then negative to n-type. So in here, malaking chance na yung negative ion natin and then positive ion will combine with each other. And then when that happens, it's like they are forming a new element, let's say electricity na lang. So it's like it's now creating an electricity or it's permitting now the flow of electricity. Okay, so your voltage is now above 0. Okay. And then when we see reverse bias, so ito yung kabaliktaran. Okay, so negative is connected to your p-type and then positive is connected to your n-type. So in here, since a diode only permits, one flow of direction, so ito, wina-widen niya mismo yung depletion region. So mangyari niyan para magiging ganito siya and then hanggang sa wala nang nagfo-flow na electricity dito. Okay? So, yeah. But meron actually dito, let's connect to the n-type. Okay. So hindi ko yata nailagay pero later on masasabi rin 'yon. In reality, so kapag nakakonect ito sa reverse bias, there is still a small voltage that can flow in this. Okay? So we do call that one leakage current, okay, or leakage electricity. So meron pa rin nakakalusot pero sobrang liit na lang wherein pwede na nating i-ignore 'yan. Pero meron pa rin konti. Okay, lalo na kapag sobrang taas nung voltage source mo. Okay. So pwedeng masira pa to kung sobrang lakas. Okay. And then here's the comparison about diodes. So as you guys can see right here, we have the voltage source. So positive is connected to the positive, the p-type, and then negative to the n-type. So there is now a flow of current. So umiilaw yung ilaw natin dito. But if it's connected the other way around, so negative to positive, positive to negative, we don't have a flow of current. Okay, we call this one the reverse bias. So forward bias and then reverse bias. Okay, so are we clear so far up to this point?
Yes, sir.
Okay, so pwede nating sabihin na same lang yung reverse bias and then the no bias. Okay, kasi parehas lang silang zero current. Okay, ang pinagkaiba lang, okay, so ulitin ko lang sa reverse bias in reality, in actual world, kung gagamit talaga kayo ng diode, meron at meron pa rin. May nakakalusot pa rin kapag magkabaliktad yung ginawa nyo, positive to negative and negative to positive. But since computation to, hindi natin makakompute yung leakage current na yan. Okay, so we could see that when I say reverse bias, zero yung current. Okay, ganun na lang. So parehas ng no bias. Okay? So forward bias conducts current, reverse bias prohibits current. Okay. So napaka straight forward. And then we have here the forward bias. So if you're going to measure the voltage right here, I hope you guys can see this one. Oops, natakpan. So i-enlarge na lang natin. Kahit na lumabo na. Okay, so if you're going to measure the voltage right here, as you guys can see, it has a reading of 0.7 volts. So just like what I mentioned a while ago, a silicon, it's a certain amount of voltage, which is, let's say, 0.7 volts. And then the rest, if we have 6 volts right here, and then just less than 0.7, this will give you a voltage reading of 5.3 volts. Okay. And then for the reverse bias, so it's the other way around. So dito pa lang pinipigilan niya na yung voltage. So we have a reading of 6 volts and then 0 volts on this bulb. Okay, or 0 current on this bulb right here. All right. So I hope we're clear with that one. Okay, so continuation. Okay, so we have this partially forward bias. So in here, it's only trying to say that in order for you to be able to make a diode work, you must have enough battery, okay, or you must have enough voltage source. So in here, if you only have 0.4 volts as your source, then hindi siya enough para itulak yung depletion region natin. So again, if we have a flow of current, yung depletion region na yan, liliit ng liliit. Okay, the narrower, the more current that it can flow. Okay, and then since meron pang space dito, parang wala pa rin kuryente or wala pa rin voltage ang dumadaloy dito. So even though this one is 0.6, 0.65, that is still not enough. Okay, and then saka lang siya gagana, okay, saka lang magkakaroon ng flow of currents kapag nag-fully collapse na yung depletion region natin. Okay, so wala na tayong depletion region, meaning nagkakaroon na ng meeting of p-type or the hole and then the electrons, so continuous sila. Okay, then we now have a flow of current. All right, so for this one, this is just a short quiz. So actually wala akong maisip na quiz nyo kasi kung magbibigay man ako ng quiz, dapat hindi siya open notes. Okay, pero since wala akong maisip and then most of them are you know, ano bang tawag dito? Parang mga sentence, mga meaning lang. So, pwede nyo kasi siyang i-search sa internet. Okay, so, pero nagbigay pa rin ako para naman may quiz pa rin sa module 1. So, yeah, sagutan nyo na lang tong short quiz. Ito, nandito na siya actually. Itong 1, 2, 3 na to. So, parang bonus nyo na to. Okay? 1 to 4, sorry. 1 to 4. Okay, so parang bonus nyo na to. Sagutin nyo siya para may 25 points na kagad kayo. Okay, and then ano pa ba iba activity? So ito na lang, case study number 1. Ito na lang siguro yung para magiging pinaka-points nyo. Kaya kung papansinin nyo, mas malaki to kaysa sa quiz nyo mismo. Okay, the discussion is 50 points and then the quiz is just 25 points. So you're going to have a proper quiz soon kapag meron na tayong computation part. Okay, so for now, basic muna, mag-relax muna kayo. And then lastly, the conclusion. Okay, so semiconductors are materials whose electrical properties lie between conductors and insulators. Okay, most likely silicon lang yan. Iba naman germanium or gallium arsenide. So p-type, so meron tayo, mas marami tayong holes, and then n-type, mas marami tayong electrons. Okay, and then diodes are electronic devices created by bringing together a p-type and then n-type region. Okay, within the same semiconductor lattice used for rectifiers or LED or any other components that you can come up. Okay, and then here's the forward bias and then reverse bias. So forward bias connected to the positive or tied to positive. So positive to positive, ganun na lang. And then negative to negative. And then reverse bias is positive to negative and then negative to positive. So forward bias has a smaller depletion region. Well, in fact, dapat wala to, okay, kapag forward bias. And then reverse bias, ang mangyari niyan, imbis na i-compress niya, since baliktad nga, palayo. Okay, so na-attract sila palayo. Wherein, ang nangyari niyan, wala nang flow of current. Okay, wala nang dumadaloy na electricity. So that is why we have a wider depletion region right here. Okay, and then here are the characteristics of diode. So diode always conduct in one direction. Diodes always conduct current when forward bias. okay, or zero resistance, and then diodes do not conduct when reverse bias. Okay, so parang sinasabi nila infinite resistance. Pero meron pa rin, okay. So I think na mention dito. Hindi pa yata dito. Mamaya pa yata. Pero end na to eh. Saan na yun? Anyway, hindi nabanggit. But yeah, ulitin ko lang. Sa reverse bias, meron pa rin. Okay, in actual. We call that one the leakage current or leakage voltage. So voltage across a forward and reverse bias, so it can be demonstrated through the use of solid state physics that general characteristics of the semiconductor light can be defined by the following equation for the forward and reverse bias regions. So for this one, okay, sa next meeting na to. Okay, kasi dito napapasok yung computation natin on how to compute this voltage right here, this current right here, and so on and so forth. Okay, so that's it for now for this module 1. So any questions so far? Okay, so none, sir, coming from Mr. Soriano. How about the others?
None, sir.
Please,
Wala naman,
ma'am.
sir.
None, sir.
Okay. All right. So time check. I think it's only have 30 seconds left. But anyway, so okay, so that's it for today. So meeting adjourned. Goodbye and thank you guys for coming. Okay. So just in case that you have a question, so feel free to message me anytime. All right. So
Yes, sir.
keep safe.
Bye, sir.
Goodbye.
Thank you, sir. Bye
Thank you,
po.
sir.
Thank you too.
Thank you, sir.